This is project 3 video number 2, the one in which we coded up. I'm going to go to Matlab, edit, and let's make this small enough so you can see it. Go function, and what I'm drawing a diagram for two-slit interference max. I don't think I need to return anything. I think I'll just call it interference max, and it's a function of two variables, lambda and the slit spacing. I think I'll call it lambda comma d, and I gotta look that up to make sure I got the right order according to the project description. And the answer is yes. It's supposed to be wavelength in nanometers and slit separation in micrometers in that order. Alright, so lambda and then d, and I'm going to go type the end of my function, indent so everything's inside the function. Let lambda in meters be equal to lambda times 1 times 10 to the minus 9, and d in meters equals d times 1e minus 6. Micrometers times 10 to the minus 6. So I'll get those in there right away, just in case I forget. Okay. Let's see what I had in mind for doing. Draw the box was supposed to be the first thing I was going to do. Let's see. I need to use line. I already looked this up, but I had to look this up. So it's the line command, create a line object. You go line xy, where this can be an array. The x can be an array of x values and an array of y values. So if it's x1, x2, x3, and this is y1, y2, y3, it draws a line from x1, y1 to x2, y2, and then from there to x3, y3. So I'll go ahead and under attribution, I'm going to go percent attribution used for information on how to draw a line. Now, if I got it right, the idea is I'm going to use axis off. Yeah, I think I'll leave that on so you can see why it comes in there. But I'll go line from I think it goes, yeah, put x in there as 0. Actually, I want to start my x and my y at the same time. So I'm going to go from 0, 0. So the first x is 0 to, and then I'll go straight up. It's like this is 0, 0, and then straight up there would be 0, 1. So 0, 1, and then so I'll use the outside of this box as the box. So I go from here to there, and then this would be 1, 1 for a square. So 1, and then 1, and then I'm up to the right hand corner. The next one would be, I'm still 1 over, but at the 0 for y, so that would be 1, and then 0, and then I got to go back to the start, which would be 0, 0. So line calls for an array of x values, comma, an array of y values, and that should do it. And I want to draw that central max line. I'm going to try it from 0.5, and then 0 would be the coordinates of, again, I'm looking at this as a square, and this is the middle point right over here, so 0.5 over and 0 up, and then I got to go up to 0.5 over and 1 up. So 0.5, 1. The coordinates of the second point. So this line goes from 0.00 to 0.1 to 1, 1, etc. This one goes from 0.5, 0 to 0.5, 1. So let's see if that actually works. I'll do a Control S. I gotta save it as, what's it call it, dummy. So maybe I did something wrong there. I'm gonna close that. My dummy variable is supposed to be equal to the function name. So I'm gonna try saving that again. And this time it wants to call it interference max.m, and hopefully I'm in the right directory. Okay, and I want to run that. So I'll go to Matlab, and yeah, there it is, interference. You know what, I don't even like the name of that. Editor, interference, I'm drawing it. Oh, I see it, I'm drawing all the interference maxima. So I was going to call it an interference diagram, but interference max is okay. So I guess I'm okay with the name of that. So interference max, and I'm going to try 650 nanometers. Well, 660. Let's go 666. 660 nanometers, comma, and then let's make it a half a millimeter, which would be 500. We'll make the slit spacing a half a millimeter, which would be 500 micrometers. 500 times 10 to the minus 6 meters. Alright. Be the same thing as 0.3 times 10 to the minus 3 meters. And it was supposed to be max, so let's try that. And it looks like I've got a box. I don't know, I guess it does look pretty square there, but I've labeled the edges of it with axes values. I think I'll shrink this down so you can see it all at once, then change the size so it looks pretty square. So there's my central max, but I want to get rid of these numbers around the edges. That's what axis off is supposed to do. So let's try axis off, semicolon. I don't think I need any of these on there. I don't need them to print. I don't think it was anyway, but I'll go ahead and put semicolons at the ends of all of them. Yeah, it didn't print anything. So let's see how my diagram is looking now. Okay, so I just got the diagram itself without any axis labels or ticks. Alright, so let's get back over to calculate the maximum sine. So max sine is equal to the sine of theta max, which is arctangent of a half. You know, I think this is going to work out since I decided to go with sines rather than worrying about actually trying to calculate the angle. Remember, I was worried in here I might wind up trying to take the arcsine of something that was greater than 1, but it also works out for me because I don't really care whether Matlab does this in radians or degrees, because I'm going to calculate the angle and then take the sine of it right off the bat. So let's do that. Theta max is arctangent of a half, and then sine. What I call that max sine. I think I'll stick with it in case I'm referring to this diagram later on. Max sine. Alright. Max sine is equal to the sine of theta max. So again, if this thing operates in radians mode, which it actually does, theta max is in radians, and but then I take the sine of it, and I just get a number. So it doesn't, as long as they're both consistent with each other, it doesn't matter whether they're degrees or in radians. Alright, what next? Get max sine. Let's go back to the code outline. Max sine, set m is equal to 1 and calculate the sine of theta. It's m lambda over d. So m equals 1. Then sine theta for m is equal to 1 is equal to m times lambda in meters divided by m lambda over d in meters. It's like 10 meters. Let's see if that's what I really wanted. M lambda over d. Okay, that looks good. And then I'm supposed to create this while loop. While sine theta is less than or equal to sine theta max. While lowercase sine theta is less than or equal to max sine, which is the sine of theta max. Do a bunch of stuff, and that'll be for ending the while loop. And then what do we have to do in that while loop? Calculate y is L times the tangent of theta, where L is equal to 1. So y is equal to 1 times the tangent of theta. I think I'll just call it the tangent of theta in meters. So y equals tan tangent of theta. Ooh, I think I had to do a little bit more than that. So I think I am okay. Now I know sine of theta is less than max sine of theta, which is less than 1 itself. So let's see if I actually had some more up there when I said calculate y. Yeah, y over L is equal to tan theta. So, oh, here it is. Theta is equal to the arc sine of m lambda over d. So theta equals arc sine of sine theta, which I had already calculated. So y is equal to the tangent of theta. Again, I don't care that this gives something that's in radians, because as long as it's the tangent is assuming it's in radians, it doesn't matter. I do want to try play around with the arc sine here a little bit. Arc sine of 1 so help arc sine. Okay, I'm not so sure that we've got an arc sine function. Try a sine of 1. Ooh, this is looking good. I think the arc sine of 1 is 90 degrees, which is pi radians. No, it's pi over 2 radians, and pi divided by 2 is 1 point. Okay, so a sine is how you do the arc sine. A sine. And we do say that it comes out in that. I guess I could do one more check. The arc sine of 30 degrees should be a half. No, arc sine of a half should be 30 degrees. So it's a 1, 2, square root of 3 triangle. So it's 1 over 2 is the sine of the angle. So 1/2 is the sine of 30 degrees. The arc sine of 1/2 should be 30 degrees. A sine of 0.5. And then I'm going to multiply it times 180 degrees divided by pi. So I don't have to think about how many radians it is. Yeah, it gives 30 degrees. So a sine is working. It gives the arc sine of a value finds the angle in radians. Okay, so I get the angle in radians. I take the tangent of it. The tangent assumes it's in radians, so that's good. I multiply times 1. I go 1 times. I know it's obviously the same thing, but just to make it self-documenting. So that tells me how far over it is, and then I think I'm supposed to draw the lines. So I got the y, calculate the y, and draw the line. Alright, let's, okay, pretend this is my box again. I know it doesn't look very square, but I'm supposed to go from here to, I'll say over here. So it'll be line And then you got to put the x and y values inside there. Alright, that's the whole thing. I just need a list of x values and a list of y values. And the coordinates of the first one are 0.5 meters over and 0 up. And I'm drawing that up to 0.5, well, over, yeah, I guess to a point to the left, that's 0.5 minus whatever I just calculated for y, and then comma 1 meter. I'm at the 1 meter position there. So that actually draws the first line. M is equal to one line to the left of the central max, and then I copy that, but with a plus sign in there for the M is equal to one line to the right of the central max. Okay, draw the two lines, and then bump up M and calculate the new sine of theta. So M is equal to M plus 1. And sine of theta is this expression. Then I'm ready to go. Go back to the while loop. Check to see if the sine of theta is less than max sine. If it is, draw another pair of lines. And if I calculate sine theta and it turns out to be greater than the max sine, then I quit, go over to here, and that's the end of it. Let's try it. So that's where I was just playing around. I'm just hitting the up arrow until I get to where I wanted to be. And I would say either that didn't work for me, or it shouldn't. So might be the arguments. So like my pattern is to spread out. The first order max is greater than whatever the angle is from between this line and the theta max line. So if I want the pattern to be less spread out, m lambda is equal to d sine theta. I'm gonna think about that. Just m lambda d sine theta. Oh, yeah, this is really it. Sine theta is m lambda over d. If I want to make the angle smaller, I can use a bigger d. Yeah, let's try that. So to make the angle smaller, I'll use a bigger d. So let's just call it with bigger d values. Oh, I got an issue. I didn't notice that. Sine theta is undefined. So, well, sine theta, oh, I see, I call the sine with an E in there, as I did here. Let's try that again. Control S to save it. Get rid of this old version of the diagram. Try running it again. And this time I got so many lines that it looks like a triangle there. And so I got a whole bunch of very closely spaced lines. I want to spread them out. So to spread them out, I make d smaller. So let's try going back to here. Oh no, just got to run it again. Let's try 50. So that's 50 times 10 to the minus 6 meters. I'm going to try Control S. Cancel. I just want to run it again. I don't have to save anything. Let's look at the diagram now. Still filled up. And let's try 5 micrometers. Alright, now we're getting someplace. So at 5 micrometers, I get the central max and 1, 2, 3 more. So let's see. I think I should probably do some checks on that. I think I'll calculate for that combination what the n would be if it were all the way out here. Now I'm hoping it'll be 1, 2, 3. It'll be between 3 and 4. So these things only occur in integers, but if I solve for n in m lambda is equal to d sine theta, I should be able to find that if this diagram is right, 1, 2, 3, it should be 3 point something, meaning the actual line corresponding to the max angle where I actually get the constructive interference is n is equal to 3. So I want to go back to my scratch pad here and just as a check. So for a check, check if what was I using for if lambda is 660 nanometers and the slit separation is 5 micrometers. Oops, I want to be back here. .660 nanometers. D is equal to 5 micrometers. We have m lambda is equal to d sine theta. So if m, I want to find oh, I know what I want to do at theta max. If I had a maximum there, what would m be? So m would be equal to d sine of theta max over lambda, where theta max is the arctangent of a half, which is equal to, I think I'll go ahead and find out what that is. Let's get my calculator. I'm getting 26.565 degrees. So m would be, d is, you know what, I'm going to convert everything to nanometers. So this will be 5,000 nanometers. I shouldn't say everything, just this value, because this is already in nanometers, times the sine of 26.565 degrees divided by 660 nanometers. So I didn't have to have SI units because the nanometers cancel. And I get m, it's a pure number, just it's supposed to be an integer, but because I picked an angle that where I don't necessarily have a max, I expect it to be between integers. So I get that on my calculator. I go 5,000 times sine of 26.565 divided by 660 and I get 3.38. 88. In other words, I should see the m is equal to 3 max, but not the m is equal to 4 max. And that's just what I had in the diagram. I got the 0, 1, 2, 3, but the 4 would be over here, which is not in the diagram. I do want to see if this thing looks square by default. If not, I want to try axis square. It actually does on my computer, you know, by default. Oh yeah, it just barely fits in the frame where you can see it. I think this distance across looks very close to that distance up and down. So I don't think I'm going to worry about commands to make it come out square by default. It looks like it's coming out pretty square by default. So this is the diagram that they wanted. And again, if I increase the wavelength, it should spread the pattern out. We can actually play around with this for a second. So if I increase the wavelength, let's go to 770. It's a longer wavelength. Let's see if that makes it so that the pattern appears to be more spread out. And I'd say just the opposite. So I think what I got to do is get rid of that graph and then try running it again. Yeah. Now, is the pattern really more spread out? Yeah, instead of 3 of them to one side, I got just 2. So the third one would occur so far over there that it's not. What else could I play around with? Oh, that's about it. So I'll go down to 500. That should make it so that I get more of them in there for that given slit width of 5 micrometers. And again, going to start from scratch here. I don't want to put one graph on top of the other. And yeah, I got more of them now. So I realize I'm not going to, so it doesn't look like a square anymore. I'm going to resize this. But I got 1, 2, 3, 4 to either side for a total of 9, presumably the one in the middle and 4 to each side. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I guess it'd be nice to print what our wavelength and number is. I think I'll actually try that. It's not required, but I'll try printing over here. Let's see, this is 0, 0, and this is 0, 1. I'll go like try start at point. Try 0.1, comma 1, and then yeah, lambda. Okay. I'm going to try text. Yeah, 0.1, comma 1, comma lambda equals, and then num to string. I think I gotta go. Yeah, I think I'll just leave it there. It's wasn't called for, and it will take a while. A lot of programming just to get that written in there, right? So I think I'll leave it just like that. Let's make sure it's still working. So I'm going to do a Control S, although it already appears to be saved. Get rid of this baby. Let's try to make it so that we do get a whole bunch of them. I'll make that 20 micrometers. oops, hit the up arrow, then change that to 20, and yeah, I do get a whole bunch of them there. So it does still appear to be working. So close that out. Did get my attribution in there just to make sure I didn't forget that, but I think I've got the code written up. And it's probably better to document it as you go along, but I am in the habit, I have to admit, of documenting it afterwards. So I'm going to save video number 3, save the documentation for video number 3. I'll call this a wrap on project number 3, video 2.